Okay, so we're still on differential equation using integrating factor. We know that the first thing we need to compare is to check if it conforms to our standard formula. Y, which is qx. So from here we can tell that our p is minus 3 over x plus 1 and our q is x plus 1 all raised to power 4. Yes. So we can compute for our x integrating factor, which is this. So our p, we know it. So that's minus x plus 1 dx, which is we can take in the 3 outside. So we have 1 x plus 1 dx. So there's a rule in integration that whenever the derivative of the denominator can give us the numerator, our answer becomes the ln of the denominator. What I mean is, if I differentiate this denominator, what am I going to have? 1. So that means my answer will now be the ln of what I have in the denominator. So my integrating factor therefore becomes the ln x plus 1. Let this one go here. So you have that. So we have gotten our integrating factor. The next thing we need to do is the last step. Integrating factor multiplied by y, then integral of integrating factor qx dx. We need to compute for this. Well, we have value for all of that. So, but before we can do that, there's E here. There's E here. I omitted it. And remember what I said in the previous video? So, because there's exponential here that is carrying this, so my answer, exponential carrying ln, so the answer is not going to be, which is the same thing as, so that's that. So now computing for this thing that we have here, so our integrating factor is what? This is it, multiplied by y, integral of then multiplied by x, qx, cqs, see it, or q rather, then dx. Wow, this is interesting. So we have our y plus this. Then if this cancel this, you are left with just 1. So integral of x plus 1 dx. So I can easily integrate this. So this one will give me x plus 1. To integrate this, I have square. To integrate this, I have x, then plus c. So I could easily make y subject of formula, so that I will have x plus 1 all cube equals to x squared 2x plus So you have this. So you could decide to further simplify it, or you could leave it the way it is. You could further simplify it, or you leave it the way it is. So again, a question will be given to you, and then when it is given to you, you try to compare it with the standard. After comparing, you find your integrating factor, which is this, and we did just that, and then we landed here. Then you substitute into the final expression. I think that's quite simple and straightforward, right? Yeah. So keep following, keep sharing, keep liking, and as I dissolve more engineering mathematics problem on my page, till I come your way again. Bye.